Hi, this is Mark Maclaine. In this session, I'm going to be looking at surds. Surds are a way of breaking down square roots into a form that's easier for us to calculate. For example, in the olden days before calculators, to work out the square root of 20, we would actually have to work it out manually. So we'd say something like 4 times 4 is 16. 5 times 5 is 25, so we know the square root of 20 will be somewhere between the two of those, so we might try 4.5 times 4.5 and so on, and this would take a long time. Now, instead of doing that, what humans found is that we could break square roots down into constituent parts, meaning that we would only really have to know the square roots of some basic prime numbers, and that would make things a lot easier for us. So, for example, the square root of 20 can actually be broken down into 2 times the square root of 5. Okay, now I'm going to show you how we do that using surd rules now. Okay, so the first rule of surds is this, that if you have the square root of a number times by another number, those two numbers can be separated out into 2 square roots. So, for example, if you had the square root of 4 times 5, that would be separated into the square root of 4 times the square root of 5. We'll be looking at that more in a bit. Now, rule 2 is that if you have the square root of a number divided by another number, those can be separated out as well into 2 separate square roots. By the way, for both rules 1 and 2, you can actually work backwards as well. So you could say if you had the 2 square roots multiplied together, they can be put together back into the same, under the same root as well. So it actually works both ways. Same thing goes for rule 2. Now, rule 3 is that if you have a square root times by itself, the square root actually disappears. So, for example, if I have the square root of 3 times the square root of 3, the answer will just be 3. That's because when you times the square root by itself, it's the same as doing essentially just squaring that square root. And the opposite of square rooting is squaring. The opposite of squaring is square rooting. Rule 4 is it means that if we have 2 square roots, say, for example, 2 root 3 plus 3 root 3, as long as these roots here are the same, you can add them. So let me quickly just give some space so I can do this. Let's have a look. Now, what we have here is, say, for example, we've got a root x plus b root x. That will give us a plus b. We can actually add the numbers in front times the root x here. And here's an example. If we have 2 root 3 plus 3 root 3, as long as the roots, the root 3's are the same, we can add the numbers in the front. It means it very much works just like algebra. So 2x plus 3x would be 5x. Now, the last rule we'll be having a look at is this. If you have a square root on the bottom here, this is known as an irrational denominator. So your denominator, the number on the bottom, is irrational because it's a square root of, say, square root of 3, square root of 5, of any prime number. So what mathematicians don't like having square roots on the bottom. So what we can do is we can multiply that by itself. And just as we saw with rule 3, if you multiply a root by itself, it will cancel out to just give the b as the denominator here. But of course, if we multiply the bottom by root b, we also have to multiply the top by root b, and what we end up with is a root b over b. So we'll be looking at more of these in a bit, but just wanted to make sure I told you that if you have a square root on the bottom, you then need to multiply by itself, and that will actually get rid of the root. We'll also look at a little bit more complex examples in a sec too. Okay, so let's have a look at this first one. Now, if you put the square root of 80 into a scientific calculator, it will actually break it down into this form here, a root b. It'll give you a number and then a square root. I'm going to show you how you can find that yourself. So if we take the number 80 and we break it down into prime factors, any problem, have a look at my video on prime factors. But 80 could be split into 8 times 10. Of course, it could also be into 2 and 40. The good news is it doesn't matter how you split it. You'll always end up with the same answer. 8 is 4 times 2, and that's a prime number, so we circle it. And 4 is 2 times 2. 10 can be split down into 5 and 2. Okay, so we can see that 80 is the same as 2 times 2. So we've got 2 times 2 times 2 times 2. So that's 4 of those. 2 times 2 times 2 times 5. Now, if we go back to rule 1, we can see that that means that if we have the square root of 80, that's the same as the square root of 2 times 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 the square root of 5. Now, let's have a look at rule 3. Rule 3 says if you multiply any square root by itself, for example, if we have the square root of 2 times the square root of 2, what that actually gives us is 2. And again, we have another square root of 2 and square root of 2, or root 2, and that gives us 2 as well. Sadly, this 5 is on its own, so we've just got this. But we can see that that is 2 times root 5, which it simplifies nice and simply to 4 times root 5. So that is the answer there, and it is in the form a root b, where a and b are integers or whole numbers. So again, if you put root 80 into the calculator, you'll actually get 4 root 5, and this is one of the easiest ways of getting it. Split it down into prime factors and then find the pairs, and then that'll help you find the answer. Let me give you another example. If we take 360, that can be broken down into 36 times 10, which is 6 times 6, and that is 5 times 2 here. The 6's can be broken down into 3 and 2, and again 3 and 2, which means that the square root of 360 could be written as the square root of 2 times 2 times 2 times 3 times 3 times 5. Again, and if we look at rule 1 here, we can see that any square root that's at the a times the b can be split out into root b. So what we've got here is root 2, root 2, root 2, root 3, root 3, root 5. So in total, there we go. Now we've got this pair of root 2's, which will make 2. Just remember, with this rule 3 here, so for example, if you have root 3 times root 3, that's the same as root 3 squared, and the opposite of square root is squaring, so they cancel each other out to give you the 3 there. So we've got root 2, which gives you the 2. This root 2 is on their own, so they'll stay that. We've got a pair of root 3's, which will make 3, and this 5 here, this root 5 will stay root 5. Now, of course, we can then multiply these as 2 times the 3 will give us 6. And then we've got the root 2 and the root 5 there. So now this is expressed in the form a root b root c. But the question is asking us in the form a root b. So what we can do is recombine our square roots to make 6 root 10. I find this method of splitting down numbers down into their prime factors very, very simple. Obviously, once you get your head around splitting that down, it allows you to arrive at the answer fairly easy with very little thought. Okay, so let's have a look at some other examples. Now, from above, we can see that rule 2 says that if you have a number divided by another number all in the square root, it can be split into 2 different ones, but also, of course, it works backwards as well. So if we have the square root of 40 divided by the square root of 5, hopefully you can see that so the square root of 40 over root 5 can also be written as 40 over 5 here, which will give us the square root of 8, because 40 divided by 5 is 8. Now, then root 8 can be split down, so we know 8 is the same as 2 times 4, and the 4 can be split down into 2 times 2. There we go. So we know that root 8 is the same as root 2, root 2, root 2. And again, this pair of root 2's makes 2, and that gives us that. So that is our answer there. The answer there will be 2 root 2, like this. Now, of course, it is also possible to try and break down root 40. Here, if we do 40 on the top, 40 would be 4 times 10, which is 2 times 2, and that's 5 times 2 there. So we can see that root 40, root 40 is the same as root 2, root 2, root 2, root 5. Our pair of square roots, of course, would cancel down to mean that this is 2 root 2 root 5. Root 5 on the bottom, of course, we'll just say is root 5. So what we get is this is over root 5 here, and the root 5s will cancel, leaving us with just 2 root 2. Okay, but I'd say that takes a little bit longer. You're best off actually just simplifying it like this straight away. Okay, let's have a look at question 4. Now, what I've been asked to do here is simplify this. Now, just like algebra, we can sort of treat this just like algebra, where what's happening here is the root 2 in front of the brackets is being multiplied by the 3 and then also by the root 2 there. So what we end up with is root 2 times the 3 gives us 3 root 2. Now, in general, what we do is we write the number that doesn't have the root in front of the root. It just makes things a little bit easier. So root 2 times 3 is 3 root 2. And then root 2 times root 2 here, okay, will give us root 2 times root 2. And then hopefully you'll recognize when any roots times by itself, it'll cancel out. So we end up with 3 root 2 plus 2 as our final answer there. Now, let's have a look at this next question here. Now, just quickly going over these rules. Remember, if we have a look at rule 4, if you have, say, 2 root 3 here plus 3 root 3, as long as the root 3s are the same, it is possible to add them. Or in this case here, root 20 and root 45 are not the same. So what we can actually do is split them down. So let's have a look at this. So root 20 can be broken down into 2 times 10, which is 2 times 5 here. So we can see that root 20 can be written as root 2, root 5. Again, that doubling up of the root 2 will give us 2 root 5. Now let's break down 45 here. So 45, I know, is 5 times 9. 5 is a prime. 9 can be broken down into 3 times 3 there. So we can say that root 45 is the same as root 3, root 5. Again, we have our pair of root 3s, which gives us 3, and that's root 5 there. And then because the whole thing has been added, it's this one plus this one, as we can see from the question here. And hopefully you can see, because there's the root 5 and the root 5, they can be added. Just like 2x plus 3x would give us 5x. Well, in this case, what we get is 5 root 5, because 2 root 5 plus 3 root 5s gives us 5 root 5. Now, with this question, it's exactly the same. We can't minus root 18 and root 2, so we can't take away the root 2 from the root 18 because they're not the same root. However, if we break them down, so let's have a look at 18 can be broken down into 2 times 9, which is 3 times 3. And then, of course, you'll see that so root 18 can be written as root 2 times root 3 times root 3. Notice how I write them in ascending order of size. And of course, that is root 2 times by 3. So that would be 3 root 2 minus, we're taking away here. We're going to be taking away. And then what we've got is that's just a normal root 2, which can't be broken down. So what we've got here is 3 root 2 minus root 2. Now, this is the same as 1 lot of root 2. So 3 minus 1, you'll recognise, is 2. So the answer will be 2 root 2 as an answer for that one. Now, let's have a look at the next one here. Now, the rule 5 of Surds here says that you can't have the root on the bottom. That's known as an irrational denominator. So what we need to do is something called rationalizing the denominator. We need to turn this denominator, this root 5, so that it is not a square root, okay? It doesn't matter how complicated the top gets, but we just need to make sure that the bottom is not a root. So what we do is this. If we've got the question is 2 root 5. Trick here is to multiply the bottom by something that will get rid of that root. Now, as we know from the rule 3 above, that if we times root 5 by itself, what we'll end up getting here is 5, because root 5 times root 5 is 5. Now, of course, if we multiply the bottom by root 5, we also have to multiply the top by root 5, and that will keep this fraction here at the start the same. Essentially, if you multiply by root 5 over root 5, that's actually just the same as multiplying by 1, so it keeps it the same. But what it does do is it serves to rationalize the denominator to get rid of that root on the bottom. So what we've got here is root 5 times root 5 gives us the 5 on the bottom, but 2 times root 5 gives us 2 root 5 on the top, and that is our final answer. Again, it doesn't matter how complicated the top gets as long as the bottom doesn't have the root on it. Now, for this next one, it's a little bit harder. Now, I didn't cover this in the rules, but I'm going to just quickly explain that if you have, say, for example, 2 plus root 3 here, and if we multiply that by root 3, the problem is the root 3 will times by the 2 and also by the root 3. So we'll end up with 2 root 3 plus root 3. Root 3, of course, will give us that, but we still have a root on the bottom. This is our denominator here. Okay, so denominators, and so multiplying by root 3 doesn't work. But what we can do is we can employ the rule of the difference of two squares. Now, the difference of two squares you'll recognize is, say, for example, you've got x plus 2, x minus 2. What will happen here, we'll have x times x gives us x squared, x times minus 2 gives us minus 2x, x times positive 2 gives positive 2x, and that will give us this. Now, hopefully you'll see that when we have a number, we have two numbers, so this number here, this 2 here and this 2 here, one is negative and one is positive. What we end up doing is these ones will actually cancel out to give us x squared minus 4. Okay, now how does this apply to roots? Well, if you're doing, say, root 2 plus 3, okay, and root 2 plus 3, if you multiply those currently, what you're going to end up with is a whole bunch of these root 2's in there. But if you make one of them minus, what that means is you'll get your root 2 times your root 2, which gets rid of our root 2 here. So that's just 2. And then root 2 times minus 3 will be minus 3 root 2. Oh dear, it's still got a root in it, but have a look now. Now what I'm going to do is 3 times root 2, which is 3 root 2. And then 3 times minus 3 is minus 9 here. But hopefully you can see that this one here and this one here will actually cancel. Okay, so what we do here is this. We end up with no roots on the bottom. And 2 minus 9 will be fine, it'll just be minus 7. But what we do is, so if you've got this on the bottom, like root 2 plus 3, okay, just as I've got the question above, if we multiply that by root 2 minus 3, what it will actually do is it'll get rid of these roots in the middle. So let's have a go at that. Again, same thing. So we've got this question here. We've got 3 over 2 plus root 3. What I'm going to do is multiply the bottom by 2 minus root 3 here. Okay, 2 minus root 3. So it's not quite the same as the example I gave, but let's have a look. Now, of course, if we multiply the bottom by that, we also have to multiply the top. Now, why have I chosen to do 2 minus root 3? Well, the reason for that is because it is the opposite of doing 2 plus root 3, which is what we've got here. And what that should do is it should cancel out. So let's have a go at this. What we end up with on the top is 3 brackets 2, there we go, minus root 3. And on the bottom, we've got 2 plus root 3, 2 minus root 3. And if I expand this out, 2 times the 2 will give us 4. 2 times the negative root 3 will give us 2 minus 2 root 3. And then here we go, I've got plus 2 root 3. And then I've got, now this is the important part, this is the root 3 positive times the negative root 3 will just give us 3. But of course it's minus because a plus times a minus gives a minus. And on the top here, if we expand this out, 3 times 2 is 6. 3 times 2 is 6, and 3 times negative root 3 will be minus 3 root 3. Now, hopefully you guys can see at the bottom here, these ones will cancel out, leaving us with 6 minus 3 root 3 on the top, 4 minus 3, which will give us 6 minus 3 root 3 all over 1. Okay, so the final answer will be 6 minus 3 root 3. Okay, Now, I'm just going to go on to another example here. That if, for example, we're asked to simplify this is 1 over root 2 all to the power of 7. So what that actually means is 1 over root 2 times 1 over root 2 times 1 over root 2 times 1 over root 2, 7 times. So what we can do is we can actually simplify that to be 1 over root 2, and of course that's to the power of 7, and that's to the power of 7 as well, which will actually give us, now 1 to the power of 7 of course will just be 1, but on the bottom we're going to get root 2, there we go, and we're going to get quite a few root 2's. In fact, we're going to get 7 of them. There's 2, 4, 6, oh, there we are, I've written 6, there we go, 6, and there we go. So what I've actually got is 7 of these on the bottom, and again, as ever with the pairs, that'll make 2, that'll make 2, and that'll make root 2. So we end up here with 1 over 2 times 2 is 4, times 2 is 8, 8 root 2. Okay, great, but it has an irrational denominator, and so all we have to do is times that by root 2 on the bottom, and what we end up with here is root 2 on the top, and 8 times, well, this is 8 times root 2, and then you recognise that root 2 will make 2. So that is root 2 on the top, and 8 times 2 is 16, and this is the final answer for this question. One last one. Again, this is the same thing with the rationalising the denominator, but the problem we have is if we multiply the bottom by root 2, oh dear, we're in trouble. So all we have to do, just like we did on the one up here, we just multiply the whole thing by 3 plus root 2. Because in this case, what that will do is it'll act like the difference of 2 squares, and it'll end up cancelling out the roots. And then, of course, if we do the bottom by that, we also have to do the top by that. So what we end up with here is root 2 plus 3 on the top times by 3 plus root 2. There we go. And then we have 3 minus root 2 on the bottom, and 3 plus root 2. There we go. And so again, 3 times 3 equals 9. There we go. 3 times root 2 would be 3 root 2. And then minus root 2 times 3 would be minus 3 root 2. And then minus or negative root 2 times a positive root 2 will give us a negative 2 there. So again, just like we did on the top there, on the previous question, and again on the top, here we go, on the top here, there we go, I'm going to have root 2 times 3 gives us 3 root 2, and root 2 times root 2 here will actually give us 2, and then 3 times 3 will give us 9, and 3 times root 2 will give us 3 root 2. And again, this simplifies nice and easy. We've got 3 root 2's plus 3 root 2's will give us 6 root 2's on the top, and 2 plus 9 will give us 11. On the bottom, we can see that these two will cancel out, so that is 9 minus 2. So our answer here will be 6 root 2 plus 11 all over 7. And there's nothing else that we can do to cancel it, so that is our final answer for this question.